All right, you guys. I'm really sorry that I cannot be here again today, but we're going to get through these notes together on this video. This is not something that's very difficult. We are just talking about proportions and ratios, and it's involving a lot of the things that you did in Algebra 1. So hopefully this will mostly be a review, okay? As a quick little warm-up, just these top ones up here for simplifying, okay? So 2 over 4 obviously simplifies down to 1/2, right? So then 10 over 10 would be just 1, okay? Then 8 to 2 is another way to write a ratio rather than a fraction. So again, you're just simplifying what goes into both. So dividing both by 2 would give us 4 to 1, and that's just another way to write it side by side. Then exponents over here, if you remember, when you divide with exponents, then you subtract the exponent numbers themselves, okay? So we're dividing 12 and 2, which gives us 6, and then we subtract the 3, and then this would be a 1. So 3 minus 1, which would give us x squared, okay? So our final answer would be 6x squared. For the next one, same thing. Divide your whole numbers out in front, which would be 2. And then this one is going to be a 1 minus 4, which gives you x to the negative 3. If you remember way back, it's been about almost a year, a little over a year since Algebra 1 did this, but then we have to take our negatives, and the negatives have to go to the bottom. So it becomes 2 over x to the third, okay? Negatives always drop to the bottom to become a positive. So hopefully you're remembering that. Just a quick little reminder, and then we'll practice some more of those as we go, okay? So building into today, we're talking about ratios and proportions, and a ratio is simply a comparison of two quantities, okay? So you're comparing two amounts. Oops, writing and talking at the same time is hard. A comparison of two amounts or quantities, okay? So again, as I talked about earlier, there are more than one ways to write a ratio. We can either write it as this, 8 to 12, right, with the word 2 in the middle. You can write it as a fraction, 8 over 12, or we can write it with a semicolon in the middle, 8, I'm not a semicolon, a colon, sorry, 8 to 12 this way, okay? The biggest thing about the ratios is the same as it is with fractions, which means you have to make sure that you are putting them in simplest form when you're done and that they come in a certain order. That's the biggest deal with today, okay? So this first example, kind of going through, notice on the first one, it says a poster of 1 meter long and 52 centimeters wide, right? Then it says find the ratio of width to length. This is where your order matters. So in here, order matters, and you have to put it in the same exact order that they are telling you that it comes in. So we have to do width over length because it says to compare width to length, okay? So the width of this is 52 centimeters, so 52 centimeters on top, over length, which is 1 meter long. And notice over here, I said, think about the units. One of these is in centimeters, one of these is in meters, and we can't compare apples to oranges. So you have to make sure that you convert. Hopefully you know that there are 100 centimeters in 1 meter. So this would be 52 centimeters over 100 centimeters, which is the same as 1 meter. Then, like I said, all ratios need to be simplified. So 2 goes into both of these for sure. So if I have that, it would give me 26 over 50. And then 2 again for both of these would give me 13 over 25. And that would be your simplest form ratio. Okay? For the next one, we are looking at triangles. Okay? So this says the measures of the three angles of a triangle are in the ratio of 2 to 2 to 5. Find the measure of each angle, right? So a lot of people want to look at these and say, oh, well, it says the ratios are 2 to 2 to 5, so those must be the measures of the angles. But you guys know that in a triangle, all of the angles have to add up to what? Hopefully, you just said 180 degrees to yourself, right? So we have a couple of things here. When you're talking about finding these measurements, first you have to find the total amount that you're talking about, which is 180 degrees for us. So this is our total, okay? Then you have to find the total parts in your ratio. Okay, that means you're simply going to add up the numbers in your ratio that's given to you. So 2 plus 2 plus 5 gives us 9 total parts. Okay, well, if I have 180 degrees in my triangle and there are 9 total parts that are making up my triangle, I want to figure out how many degrees are in each part. So 180 degrees divided by 9 total parts, right? 180 divided by 9 is going to give me 20 degrees for each part. Okay, well, if we go back to our ratio and we say that the angles are 2 parts to 2 parts to 5 parts, we should be able to figure out what each angle measures. So if the first angle is 2 parts and each part is 20 degrees, I'm multiplying those, which makes it 40 degrees. The second one is also 2 parts, so each part is 20, which gives me the second angle as 40 as well. Then the third one is 5 parts, so 5 times 20 for each part gives me 100 degrees. Now, this should make sense as your answers because 100 plus 40 plus 40 makes 180 degrees total for the triangle. Okay, so number 3, the ratio of the measures of two complementary angles is 4 to 11. Okay, so 4 parts to 11 parts. And the word complementary, hopefully you remember, this means 90 degrees. Okay, so if I'm kind of drawing a little picture here, this would be like 90 degrees, right? 2 angles that make that up. This one's 4 parts, this one's 11 parts. So one should be bigger than the other. Okay, together they make 90 degrees total. Remember, you said you had to figure out how many total parts you have by adding them together. So 11 plus 4 gives me 15 parts. So then I'm going to divide 90 degrees divided by 15 parts means that each part is 6 degrees. Okay? Now, if each part is 6 degrees, then that means that my first angle is 4 parts times 6 degrees for each one gives me 24 degrees for my first angle. My second angle is bigger. It's 11 parts. 6 degrees for each one gives me 66 degrees. And again, this is complementary. So these two need to add up to 90 degrees total. And they do. Okay, so there's your answer. Okay, so moving forward, we have ratios that we've been talking about, and ratios together make proportions. Okay? The thing is, the two ratios have to be equal. So, a proportion is two or more equal ratios. Okay? So, example, anything you want. So if I said 5 over 6 and I wanted a ratio that was equal to that, it would be something like maybe 10 over 12, where all I'm doing is multiplying both the top and the bottom by the same number, 2. I could put something like 10 over 15, and an equal ratio would be like 30 over 45, multiplying both of them by 3. I could even do one that was 100 by 150, multiplying both of them by 10. Anything that you do that multiplies both top and bottom by the same number creates an equal ratio, which then makes a proportion. Okay? So on the top back of your notes, we are actually going to solve proportions. Now, hopefully you remember how to do these. It's been a long time, probably maybe even 6th or 7th grade, okay? But these can be solved by cross multiplying. Okay? You're going to cross multiply, and then we're going to solve the equation. Okay? So, first one, if I take x times 8, I get 8x. Then 3 times 12, I get 36. These two are equal to each other, so I put an equal sign in the middle, and then we just solve. This is a one-step equation, so divide by 8 on both sides. These cancel, and x equals 4.5. And you're done. We're trying to find out what number goes here to make these two ratios equal. Okay, same thing here. Cross multiply gives me 12 times, and this is an expression this time, so you have to do the whole thing, x plus 3. Then multiply the other way. 18 times 2 gives me 36. This is distributing, just like normal. Super easy. Algebra 1 stuff you guys have already done. So 12x plus 36 equals 36. Now we have a two-step, so we're going to subtract. Those cancel, and I've got 12x equals 0. And when I divide by 12 on both sides, then I have x equals 0. Okay? Now this next one goes way back. So when I multiply here diagonally, I get x plus 3 times x minus 2. Now, if you guys remember, again, about a year ago or more in Algebra 1, when you had a 2 by 2, you did this little thing called the box method. And you had to plug these numbers in. So x plus 3 and x minus 2 go on the sides and the top, doesn't matter which order. Then we multiply and we drop the answers in the box. So x times x gives me x squared. X times 3 gives me 3x. This is negative 2x, and then negative 6. These across here combine like terms. So we've got x squared. 3 minus 2 gives me 1x, and then I have negative 6. Okay? Then, going the other way, I've got x times x plus 2. So I'm just distributing. Multiply here and here gives me x squared plus 2x. Now, those are your two answers, so we're going to set them equal to each other and combine like terms to solve. I just took this one up here and put it on the other side, okay? So if I subtract x squared to get those together, then they cancel on both sides. I'm left with 2x equals x minus 6. Move your x over to combine those. Now I've got x equals negative 6. And there's my answer. Again, I know that's a lot of review. Hopefully that's coming back to you as you see it. You can practice it a little bit with your homework tomorrow, and you'll be good to go, okay? We're actually going to skip number 5. It's just asking you what you do to recipe to make 2 cakes instead of 1. Hopefully you guys all know that you would have to double those measurements by 2, right? So double the recipe to make 2 cakes, okay? So let's talk about the next few. Those are the most important ones. I'm trying to get you through this as quickly as I can, okay? You notice the school store is having a huge sale of 65% off everything in stock. The hoodie you're interested in buying costs $42 before the discount. How much will the hoodie cost after the discount, but before tax? So first thing we talk about with percentages is that we have to actually write them as a decimal, right? So 65%, hopefully you know you take the decimal point and you go backwards 2, which gives you 0.65 as your decimal, okay? The hoodie you want costs $42, right? If it's 65% off, first you have to figure how much money that is that they're going to take off the price. To do that, you take 65%, so 0.65, and multiply it by the amount that you're trying to spend. Okay? 65% of $42 is $27.30. Okay, that should make sense because it's more than half. 65% is more than half. Okay? Now, this isn't what you're paying. This is your discount. Okay? And if it's a discount, that means we have to subtract it from what we would normally pay. So the sweatshirt you want is $42. It's discounted off $27.30, which means you are actually paying $14.70 for that hoodie. Quite a deal. Okay? So find the discount first, take it off the price, and then figure out what you actually owe. Okay, so 7, 8, and 9 are actually going back to our proportions where we're setting up those amounts and solving for like we did at the top of the page. The important part here, just like we talked about earlier, is the order that you put them in. So let me explain. A baseball pitcher strikes out at an average of 2.6 batters per 9 innings. Okay, so that's the way it's given to me. That's the way I'm going to write it. 2.6 batters. I'm just going to put batters here. Write it out for you so you can see it. And this is 9 innings worth of pitching. Okay, so the question says, at this rate, how many batters would the pitcher strike out in 315 innings? So if this is happening for 2.6 for 9 innings, how much would it be? How many batters? That's our question, right? Would there be struck out in 315 innings? Okay, so now we have our proportion, and we have to cross multiply in order to solve, just like we did on the other side. So if I take x times 9, I get 9x. If I take 2.6 times 315, we get 819. These are equal to each other, and then we divide and solve. So 819 divided by 9 gives me 91 batters. So if this person pitched 315 innings, they should strike out about 91 batters. Again, setting it up so that they match. Batters over innings, batters over innings. Okay? Same thing down here. Number 8, we have a basketball player makes 8 out of every 20 free throws that he attempts. Okay? So 8 is what he makes. 20 is how many he attempts. All right? So what we want to know is if he were to attempt 50. So made over attempt means 50 goes in the bottom. 50 attempts, right? How many would you expect him to make? So we don't know the made part up here. That's our x, our variable. Then you cross multiply and solve. X times 20 gives me 20x. 8 times 50 gives me 400. Divide by 20 on both sides. And x equals 20. So if he were to attempt 50, he would most likely make 20 of those shots. Okay? Pause the video, take a couple minutes, and see if you can do number 9 by yourself, and then come back and check. Okay? So hopefully what you have written down after you coming back to me to check, a tree casts a shadow that is 10 feet long. A woman who is 5 feet tall casts a shadow that is 4 feet long. 2 similar triangles are created. How tall is the tree? Okay, well, if we know that the woman is 5 feet tall in real life, right? So she's 5 feet tall, and she casts a shadow that is 4 feet long. So 4 would be her shadow. Then we're trying to figure out the same for the tree. The tree casts a shadow that's 10 feet long. So shadow goes in the bottom, and we want to know how tall is the tree. We're not sure. Cross multiply should give you 4x equals 50, which means your tree should be 12.5 feet tall. Okay, let me know if you have any questions about anything.